Today, we're tackling a problem that challenges us to locate every instance of a set of words within a larger text. The goal is to report the starting and ending indices for each match. How can we do this efficiently, especially when dealing with many words or a very long text? The problem, index pairs of a string, provides a text string and an array of words. We need to find all substrings within the text that are present in our words array. For each found word, we must return its start and end index as an integer array, and the final list of pairs should be sorted first by start index, then by end index. The core challenge is performing these many substring searches without excessive redundant work. A straightforward approach is to iterate through each word in our list. For every word, we then iterate through the entire text, checking if a substring of the current word's length matches. If it does, we record the start and end indices. Finally, we sort the collected pairs. While simple, this is inefficient. For each word, we're potentially scanning the text multiple times, leading to a time complexity of roughly words count times text length times word length, which can be very slow. Space complexity is minimal, just for storing the results. The key insight for optimization here is to use a trie. Instead of repeatedly searching for individual words, we can pre-process all words into a trie. This structure allows us to search for all words simultaneously as we traverse the main text. We build the trie by inserting every word. Each node in the trie represents a character, and we mark nodes that complete a word. Then, we iterate through the text, starting a potential match at each character. As we traverse the text, we simultaneously traverse the trie. If we reach a node in the trie that marks the end of a word, we found a match. We record the current start index and the current character's index as the end index. This way, we efficiently check for all possible words starting at a given position in the text. Let's trace this with text vestorio fleet and word story, fleet, LeetCode. First, we build our trie with story, fleet, and LeetCode. Now, iterate through the text. At index 0, t, we start traversing the trie. No word starts with t in our list. At index 3, s, we move to the trie node 4s. Then t, o, r, y. We find story ends at index 7. We record 3, 7. Continue from index 4. At index 9, L, we move to the trie node 4L. Then E, E, T, C, O, D, E. We find LeetCode ends at index 16. Record 9, 16. But wait, at index 10, E, E, T, C, O, D, E is also LeetCode, ending at 17. So we record 10, 17. We continue this process, collecting all index pairs, and finally sort them. For our example, the final sorted output would be 3, 7, 4 story, then 9, 16, 4 LeetCode starting at L, and finally 10, 17, 4 LeetCode starting at E. This correctly captures all overlapping occurrences and presents them in the required sorted order. You'll spot this pattern when you need to search for multiple patterns, or words, within a larger text, especially if the patterns share prefixes. If a brute force substring check feels too slow, and you're dealing with a fixed set of search terms, a trie is often the optimal data structure to consolidate and speed up those searches. The time complexity is roughly the text length times the average word length plus the total characters in all words. Space complexity is proportional to the total characters in all words for the trie. This trie approach is powerful for string matching. Try the next problem involving multiple pattern searches, it might use the same pattern. Don't forget to like and subscribe for more DSA insights.